All right, so today we're going to talk about linearizing, and we're going to talk about what that means graphically, how that can help you. It's a skill, I promise. It's going to show up everywhere in AP Physics, so that's why I'm calling it E and a zero. You know, it's a really fundamental skill to have, how to linearize a graph. So there it is, kind of like, I really think of linearizing as a it's a procedure, right? You don't really have to understand how it works. It's just, you got to kind of figure out how, or remember how to do it. And I hate I hate promoting memorizing. I was got to combine those. I hate promoting memorizing, but if this is like the one thing in physics that you just remember and you don't fully understand it, I think that's okay. But I'll give you kind of some things to think about when linearizing, so it's not so brutal on your memory and you don't forget. There's a couple different types of graphs you can get. Just pushing my chair, sorry about that. But you can get so let's say you're doing a lab, right? And you asked to graph some data. I don't know what your data is, but your y variable and your x variable. You can get like a flat, you can get like a horizontal, you can get a quadratic when you do it all and you graph it. And then you can also get a square root, or I'm gonna draw it kind of right here. You can get like a inverse relationship, and I think those are the main types. Hopefully I'm not forgetting anything, but these are usually the ones you're gonna see. So how do you linearize them? Well, the point of linearizing is that when you do the linearization process, you're gonna get linears out of it. So you're gonna get, okay, let me draw one for each one. But when it's all done and dusted, I need to get a linear. So these two are linear, right? Like these two, you don't have to do anything. If you do your lab and you get these two kind of graphs, like on pivot or whatever, guess what? Awesome, you don't got to do anything. It's just kind of there, done and dusted. But you want to get linears for all of these, right? So the way you linearize is, instead of graphing y and x, you have to graph something different so that it ends up like as a linear. So instead of graphing, so for example, for quadratic, and I should probably say which one is which. So y equals c, y equals x, y equals x squared, y equals root x, and then y equals 1 over x. So this is just which graph is which. If you want to make this linear, you got to graph y over x squared. If you want to graph this, you can either graph y over square root. The way I like to do it is just doing y squared over x. Sorry, I'm just fixing the graph. And then for this, you're going to want to graph y over 1 over x. So if you want, you can write this down in your packet somewhere, wherever. I think there is a space, or you can or you can take a photo. I don't know. I don't care, honestly. These are just how you would linearize your graphs. So let's say you got so just to kind of give you some more intuition of how this works. Let's say we got a graph that looks like y over y and x squared. And let's say, so if you're on Pivot, maybe you graph your data in. Pivot's really nice. They can tell you like what the equation of this graph is. Let's say they tell you it's, let me think of something. Let's say they tell you it's y. So let's say you're doing a lab where you're trying to figure out distance and time. So this is your change in x. I wrote an x squared here. I'm really sorry about that, by the way. And this is your time. So they give you a little equation. They say x is equal to 4 meters per second over t squared. And that's the equation they give you. And you got to make it linear. Well, you would put, and I'll just make it x instead of changing x, you would put t squared in the x-axis, because if you take a look at this equation, a linear always has the form y equals mx plus b. So y equals mx plus b. So the b in this case, right, that y-intercept is just 0. So we can get rid of that. And in order to kind of make this into a linear form, we need to graph y and x. Well, x, our displacement, is like that y variable. But instead of graphing t, in order to get a y equals mx form, we can graph t squared as our x, right? And we can put t squared here. So that really gives us the form, right? If we were to graph this now, y equals 4 meters per second. I'm sorry about this, should be squared. I'm really sorry about that. Hopefully none of the teachers who are watching this are like screaming at my face. Like, why are you fitting the squared? Y equals 4 meters per second. T squared, when your t squared is your x-axis, this becomes your slope, and then this is just your y, right? So t squared is your x-axis. In a similar way, if this was a square root, right? So I'll say, I'm not going to do like an actual like physics like equation. I'll just say y equals, let's say it's like 4 root x. Well, I got to get a y equals mx relationship. Well, what I can do is I can square both of these. I get y squared is equal to 16x. So my y variable can just be y squared. So I can get this as y, or not dividing, but this is my y, this is my x, this is my m. Boom, I have a linear equation if I graph y squared and x. So that's just another way to kind of give you some intuition of how to linearize. It's honestly, I'll probably, when I make my unit videos, I'll show you specific examples of like, okay, you're given a FG, like a force of gravity graph. Here's how you linearize that kind of thing. A big way to do it is just by looking at the equation. So for example, if you know that x is equal to 1/2 at squared. So I know that if I'm given an x versus t graph for like a constant acceleration, I don't know, object, I know that I'm going to have to graph this as y, and then my t squared is x. What's going to end up, so if this is y equals mx. If t squared is my x, and then the displacement is my y, then, or my position is my y, then this 1/2 a is going to be my m. That's going to be my slope. So then what I know is that, okay, in this case, so if the slope of x versus t squared is 1/2 a, 1/2 the acceleration, then I can use the slope, 4 meters per second squared, to solve for acceleration. 1/2 a equals 4 meters per second squared. So I get acceleration is equal to 8 meters per second squared. The slope ends up being half the acceleration. So that is just one example of how you would use linearization to kind of help you out. Hopefully this video was helpful. Let me know if you have any questions. And yeah, thank you for watching.